and in my role as chair, of that forum. In the image here is my daughter, Becky. Becky's holding a sediment core from a salt marsh up in Dornoch in the Highland region. Just in the background there is the Glenmorangie distillery. It's a wonderful part of the world. And we've been working on these habitats for a number of years. So I'm going to focus this evening on our coastal wetlands, partly because they offer us an opportunity for working with nature, working with blue carbon systems, and delivering on climate mitigation, delivering for people, and most importantly, of course, delivering for nature. And the agenda that's been referenced in terms of COP27 is really one of bringing nature into the nexus with climate. And this is a very exciting development in the global climate negotiations at the present day. I should say something about my early memories and some connection to seabirds. And the connection I'd like to make is that I grew up on the island of Anglesey in North Wales. And one of my earliest and fondest memories was being on the Mechdraeth estuary where my grandparents lived, and seeing curlews. And it was one of those wonderful sights, viewing them with binoculars with my grandfather, that's stayed with me an awfully long time. So I think doing these things early, engaging with nature, does help shape a career. And I've been very grateful for that influence on my own career. I mentioned that I'm based at the University of St Andrews, and I was recently reminded, and to give our principal a plug, I'm sure she would welcome that our strategic plan 2022-27 was recently launched. And in the introduction, Professor Mapstone made reference to something that really struck a chord with me. I've been an academic a long time, and I've lived in that very privileged environment. So I'll read it to you, and I hope this sets the scene in terms of what we are trying to achieve collectively in this endeavor. Universities exist for the pursuit of truth and scholarship, but in executing that privilege, we must also serve. And I think this is the way increasingly, as I move through my science career, that I've realized that there is an opportunity in the science that we do to support the evidence need that can make these changes. So that's what I'm going to try and focus on this evening. And as I say, it's a pleasure to be here. Now, hopefully this will move forward. So just over a year ago, the world met in Glasgow, and they met for COP26, which the UK hosted. And I was there and part, in fact, of the science, but also part of a project into the oceanic. And I'm really excited to show you this image, which is a drone-based image of a blue carbon ecosystem projected onto the building and communicating in a way, you know, the visual impact of these wonderful places that we study. And I think for me, this is something that really drives the endeavor. It's such a privilege to visit these places, to understand them, and to think about the way that they work and the way that they can be restored. But of course, our coastal wetlands, these blue carbon habitats, as we call them, are probably the most threatened habitat on the planet. Those threats come from us in terms of coastal development, processes of coastal land use change, and of course, increasingly from global sea level rise, driven by the very global warming that we're partly trying to address here. I wanted to share something about these concepts and working with nature through biodiversity. So it's about people working with nature ultimately to deliver sustainable development outcomes. And in the lead up to COP26 last year, we prepared a briefing for UK government. And in this briefing, we made a very important point. And I think the first point here in the slide is probably by far the most important when we talk about nature-based solutions. And in fact, it's nothing to do with nature-based solutions. It's about our personal consumption. And ultimately, the answer to this problem lies in decarbonizing our economies and swift and deep emission cuts. And that's a challenge for all of us, of course. And some of those emissions, as I'll go on to show, are going to be very difficult to remove. And we will come back to that question when we think about these nature-based solutions and the actions that we can take. But I did want to make that point. What I'm going to talk about is ultimately not a silver bullet to address the climate emergency. But you'll see here that the reference to emissions leads very nicely to the net zero ambitions that our governments have committed to. In fact, my own university at the University of St Andrews has committed to its own net zero targets. And in this effort to contribute to net zero emissions, of course, nature work with our greenhouse gases to sequester and store carbon. So this does give us a fantastic opportunity to both satisfy the net zero agenda, but also to restore, to create opportunities for people, and ultimately, as this paper suggests, to create opportunities to restore nature and biodiversity. Now, blue carbon habitats, I'm going to give you just a quick run through of these blue carbon habitats. I appreciate they might be new to some. Key points here are the numbers at the bottom. About 83% of the Earth's carbon cycle involves the oceans. So the oceans are a key part of our global carbon cycle. And as you know, the carbon cycle is ultimately driving through these greenhouse gas concentrations in the atmosphere, the global warming challenges that we face. But these habitats, in their strictly defined sense, cover a very small coastal fringe area. And yet, in terms of bang for buck, if you like, they store about half of the primary produced carbon in their associated sediments. So they're highly productive places, they're sequestering large amounts of carbon, and they're very effective at storing that carbon. They're also wonderful places to visit. Here's a little bit of sea pink along the coast from me at Ely, and a student's attempt, a very good student, attempt at an infographic. And this was an exercise to get students to think visually and to communicate visually about the role of these blue carbon habitats in our climate system. And I think this student did a fantastic job of highlighting how the CO2 is ultimately a cycle, and that these greenhouse gases can both be sequestered and stored in these systems, but we can also lose carbon from these systems. So there are two very good reasons why we want to protect and then restore our blue carbon habitats. I've mentioned the work of the university, and this is a fantastic slide. For me, that's my son on the left up on Morrichmore during the pandemic, when we were determined to keep going, but we had to do this in our family bubble. So I'm grateful to them for helping with some of that field work. And then more recently, the two middle slides, this is in the Inner Forth, not far from Edinburgh, not far from Grangemouth, in fact, at the close to Skinflats, the RSPB site there, if you know it. And this is Shritika Parihar, who's visiting the University of St Andrews at the moment on an exchange program, where we've been training this PhD student from India in some of the techniques that we use. And then on the far right, one of my favorite pictures from another of my PhD students. It's a rather Heath Robinson design, if you know what that means, of a sediment trap. This is up at the Kyle of Tongue with Ben Loyal in the background. So of course, this work is a wonderful opportunity to visit just some of these most amazing places that we have in Scotland. And it would be difficult not to notice seabirds. So I have slowly began to appreciate the importance of these habitats for wading seabirds in particular on the adjacent mudflats too. So a little bit of the background here. If I'd asked you on entering the presentation, name the most important carbon sequestering ecosystem on the planet, you would probably have told me that it's perhaps a tropical forest. But actually, when we look at the sequestration rates, as this diagram shows, in terms of grams of carbon taken up in each meter squared per year, so this is a fair comparison, we're comparing area by area here, we see that these blue carbon habitats, the mangroves, the tidal marshes, and the seagrass meadows, of course we have two of those in Scotland, we don't yet have the mangroves, are sequestering significantly greater amounts of carbon than their forest counterparts. Now, of course, the area of these forest systems make them extremely important in our global carbon cycle and in the climate system. But still, again, to come back to this idea that if there are places where we might focus our attention, these blue carbon habitats offer us huge potential in terms of their ability to sequester carbon. And this, of course, has attracted a great deal of interest in very recent times in terms of climate mitigation, the way that we might use the restoration of these habitats to store more carbon, and the way that we could then begin to use a voluntary carbon trading market to help pay for this restoration. And I think this is a really exciting area where we breach and cross into different disciplinary areas, but where, of course, ultimately it's the science that's going to inform the best policy in this sphere. And then again, making the point in these bottom three columns for mangroves, tidal marshes, and seagrass meadows, showing the below ground storage of carbon in their associated soils. And we see very large stores of carbon in these places. And again, this is due to the waterlogged conditions and the fact that seawater can inhibit some of the microbial activity that would normally break down organic matter in forest soils, farmland soils, etc. So we've got very high primary productivity and very good places to store away that carbon. So that means that blue carbon habitats are rising on the global agenda in terms of climate mitigation potential. And here in the UK, I've been leading a project from St Andrews focused on how these intertidal environments can store carbon. And we've been working really to map these habitats. They're pretty well mapped to begin with, but we're also now trying to understand how much carbon they store and the rates at which they store that carbon. And of course, as academics, we publish and we test these results through peer review. And these are some papers just published in the last year. The second one that I've just popped up there was really nice, and there may possibly people on this call this evening who contributed to our citizen science program. And what we did was we sent out packs, sampling packs, and we put self-addressed prepaid envelopes in with those packs. Those came back to the University of St Andrews. Some of them kept coming back over the pandemic, and they were put away in freezers. And we've recently completed the study. We've analyzed over 500 samples from across the UK, and we've been able to use this to produce a very detailed carbon. That's essentially an assessment of the store of carbon in these systems. And you may know that Scotland, of course, is one of the top 10 nations for its peatlands. And the analogy here, of course, would be that the peatlands are being restored at the present time because we understand that that re-wetting of the peatlands both restores these important, globally important habitats, but also means that they sequester and, most importantly, hold on to the carbon in that peat. And, you know, this is part of the same process that we're going through in terms of the evidence. The other things that we've been doing is trying to develop best practice, so quite technical work, but this does challenge some of the global perspectives. And in fact, you know, I'd like to make the case that Scotland, and through the support of the Scottish Blue Carbon Forum, has really been driving some very important work in this field in recent years. Now, some of you may also know the RSPB Nig Bay site is a wonderful place north of Inverness. We were lucky enough to visit and do some fieldwork there just over a year ago, and I wanted to show you these preliminary results. On the left-hand side of the screen, we see a golf hole cutter. So this is the kind of device that they would use on the old course at St Andrews to cut the holes on the tee for the putters. But in this case, we're using this device to extract a very nice intact sediment stratigraphy. And on the right-hand side, we've measured and then plotted up the organic carbon that is building over time following the managed realignment of the Nig Bay site. So this is a very interesting site. It's Scotland's first managed realignment. And in 2003, the sea was let back in to farmland, which had historically been reclaimed from the sea. So we're really rethinking the alignment of our coastlines. And this is, of course, something that we're going to have to do as sea level rise continues. But in this case, as you go up through that stratigraphy and 3 different sediment cores, you see that the organic carbon in the soils builds up over time. The profiles tell us something about the burial process and its efficiency. But ultimately, I think this illustrates that managed realignment as a management activity can enhance carbon storage in these environments. And this is what we refer to as additionality. So we get very excited in terms of additionality at St Andrews, because what we're really showing is that through the management activity of the RSPB in this scheme, they've added carbon that would otherwise have been in the atmosphere into a long-term sediment store. And I think this is a very exciting development, because it shows us that these places are actually helping us in the fight against climate change. Now, I have to say, before you get too excited, that globally, the blue carbon potential is about 3% of what we need to contribute to the Paris Agreement. And the Paris Agreement is the 1.5 degree warming targets, which is increasingly challenging in terms of current emission trajectories. But it does show us that you know, we can make a contribution. The abatement contribution from UK salt marshes is quite small again in the scheme of things. And I think what we then need to do is go beyond our thinking of carbon and think about the habitats that we're creating and the other services that they provide. And as I've mentioned already, back in 2003, I'm sure the RSPB were not thinking about blue carbon. What they were thinking about was creating important habitat for bird and wildlife in the Cromarty Firth area. And so I think this shows us that we can bring carbon together and the carbon credits that can be traded and help finance these schemes with other valuable services that nature provides us. And as someone, who enjoys going to these places and the peace that they bring, just that well-being is something that's difficult to value, and yet I think priceless as these places are lost. Okay, so I'll take you on to some of the science. The maps on the bottom right are some work that we published for the Scottish Government. Scotland has the first full carbon stock assessment in the UK. We're very proud to have delivered on that work, and it's extremely important baseline work for greenhouse gas accounting. And the cartoon on the left is from a good friend, Joe Smith, who's tried to conceptualize how these systems work. And of course, there are inputs and outputs. And ultimately, what we want to understand is how effective these places are at storing and building up a store of carbon. And we can do this in a whole series of technical approaches, and I won't go into those, but you can do this globally. You can use IPCC here stands for the Intergovernmental Panel on Climate Change. They essentially set the rule books that people follow. For example, at the COP in Egypt at the moment, they'll be following some of the guidelines from the IPCC and the recommendations from the IPCC. And that will be governed through the UNFCCC process. So that's the United Nations Framework Convention on Climate Change. But here in the UK, and in fact, Scotland has to follow the UK in terms of its greenhouse gas accounting, although Scotland can report individually on these targets. And you may in fact know that Scottish Government has a more ambitious net zero target than the UK government. UK government is 2050 and Scotland has set its target on 2045. And the objective here, put simply, is to help produce a roadmap through this science for the implementation of greenhouse gas emissions and removals from salt marshes in the UK. And I have to admit, because of these fluxes of greenhouse gases that can come out of these places, we don't yet fully understand the scale of the sequestration of carbon into these systems. And that's where some of the work needs to continue. Now in March this year, the UK Climate Change Committee produced an influential briefing on blue carbon, and we were pleased to be able to contribute to this. I'll just read you a few of the points here, but I think the first one is probably the most important one. And this is that the natural environment is recognized as playing a pivotal role in the net zero transition. And this is because these places, as I've said, can store carbon, but they can also provide climate adaptation services. And so as sea level rises, these ecosystems, if they are functioning well, can actually grow with sea level rise, as long as the rate isn't too high and there's enough sediment supply, and they will give us coastal protection. And probably the best example of this globally are our mangrove forests. So these mangrove forests provide incredibly important climate adaptation services and deliver resilience to coastal communities in some of the poorest parts of the world. So I won't dwell on the details here. It does go on to say that the abatement potential is small. And of course, this is a challenge if we're going to focus on net zero. We're ultimately going to have to focus on what will make the greatest difference to help us get there. But I'll come back to that point towards the end, because there is something in nature and the investment that we make now, which will cumulatively contribute to these efforts. And then some recommendations. I won't read these to you, other than the first recommendation from the UK Climate Change Committee is that salt marshes should be moved as soon as possible into the UK greenhouse gas inventory. And that, in a way, is wonderful news for us. If we can achieve this, we will achieve a UK-wide policy that means we really need to be focused on the protection and improved restoration, and even the creation through coastal realignment of these salt marsh habitats. So I'm very optimistic that this is going to drive important changes. The other thing that's interesting in the UK context, in the Scottish context, this is some consultancy work that a friend and I did for the Pollination Foundation. In this case, looking at the ELM scheme, which is the payment to agricultural scheme that England will adopt. And in this case, we're starting to think about management interventions, perhaps just at the sustainable farm scale or at the local nature recovery scale, all the way through to the landscape recovery scale, and how this might be incentivized through agricultural practice and some of the payments that can be made to support those good environmental practices. And of course, Brexit, I hesitate to mention European exit, but it does deliver, of course, an opportunity as we come out of the common agricultural policy to reimagine some of these payment schemes. And I think this will, at scale, potentially offer some good things for nature going forwards. And in the UK, of course, scaling up restoration projects require some key changes. You know, we need better protection of our natural habitats in our planning system. As I've said, we need to see reforms to agricultural, including forestry payments, better outcomes that benefit climate and biodiversity. We need connections between these habitats, because these habitats and the organisms that depend on them are interconnected and flowing. They're not static in the environment in the way that we might draw a line around a particular area. And of course, we want to make it compulsory ultimately for nature-based solutions to be factored into development of our natural landscape. So I'm going to give you an example of how we might rethink our coastlines now. We were very fortunate to be commissioned by Climate Exchange, which is a centre of expertise that advises government on matters of climate change, research and policy. What I'm showing you here are mid to low salt marsh habitats and high salt marsh habitats at Tyningham, not far from where some of you may be this evening on the east coast of Scotland. And in this image, you see very clearly the reclaimed agricultural land in the heart of that estuary. And what we've done is simply imagined removing those coastal defenses. So if you happen to own that land or farm that land, don't panic. You know, this is just scenario work. It's not a recommendation. And what we're looking at is the potential of our coastlines, these low-lying areas, and particularly those areas that were historically reclaimed from the sea. Their potential for re-wetting and allowing the sea back in. And what we see here is quite a large area that could potentially be restored to these intertidal wetland salt marsh habitats. And this report has been published, so you can find this on the Climate Exchange website. I'd be happy by email to answer any questions after the talk in terms of the detail of what I'm showing here. I'm rushing through this a little this evening. And again, a historical map, 1894 here, showing quite early reclamation, and in fact very large swathes of this land, not so much in Scotland but throughout the UK and across Europe, were of course reclaimed from the sea to create very productive, and I would recognize that in terms of all of the stakeholder considerations here, very productive agricultural land. But of course, that land is increasingly under risk because it is so low-lying and because sea level rise is accelerating. And then on the left-hand side, we see in orange, pink, the current extent of the marsh area. And then in green, blue, the modeled extent of what could be gained simply by managed realignment at the present day. So we see some significant aerial gains in this important coastal habitat could potentially be achieved. And I should say there are a number of these sites across Scotland. Now, what we've done in a very simple modeling scenario is we've taken the best estimates of the trajectory of future sea level rise. Of course, we don't know what future sea level rise will be, but we have an understanding through numerical modeling of how sea level might rise under different scenarios of greenhouse gas emissions. And these are called the representative concentration pathways. So in red, RCP 8.5 is the worst case scenario. This is what we really don't want to do, excuse me, which is to emit very large concentrations of CO2 into the atmosphere. And those will cumulatively build up and rapidly warm the planet and therefore drive rapidly increasing sea level rise. What we really want, of course, is a trajectory towards the blue line, where we increasingly reduce our emissions and sea level rise hopefully slows down. Unfortunately, sea level rise, because of the additional warmth in the planet and the response to glaciers at high altitude and high latitudes to that warmth, are going to continue to melt. So we are going to have to deal with future sea level rise, whatever we do to greenhouse gas emissions. And this, of course, makes the urgency for our coastal wetlands that much more acute. We are going to lose these habitats, and increasingly with coastal or near coastal infrastructure, we see a squeeze effect as sea level rises. Okay, so perhaps a bit of good news here and something to cling on to. The grey line at the bottom shows you the current marsh extent at this site. And in all but the worst case scenario of future sea level rise, and I have to add this is a very simple model, we see net gain in the habitat extent by the end of the century. And that's important. So managed realignment may be a strategy under future sea level rise for maintaining the extent of these coastal wetlands. And I think the other point to make, of course, and we have done this in the report if you want to go and look at it, is that we can model with these aerial extents the amount of additional carbon that's gained. And so these activities are giving us additional carbon. And in all but the worst case scenario, there's a significant proportion of that additional carbon that's maintained. So that satisfies the second requirement for these carbon schemes, trading schemes, which is that we have permanence and we can demonstrate permanence. And in fact, there hasn't been much of that work in the science literature on the permanence of these schemes under future sea level rise. Okay, so moving on. Excuse me. There are, of course, international agreements for the way that we should work towards these schemes. And a great deal of the focus has been in the tropics and in the protection of mangrove forests in particular. And one of the reasons for this is that the rates of land conversion of these forests into things like palm oil plantations or shrimp ponds, or for coastal development, has been very severe. And so, we need these opportunities, and we have these. So we have the frameworks to deliver these changes. And I suppose, what's exciting is that whilst we haven't done this in the UK yet, we are moving, I think, quite rapidly to a situation where we will be able to protect and ultimately restore these habitats. Okay, and then I thought because of the Seabird Centre and sort of looking out to our coastal environments and the foraging and feeding of many seabirds in the offshore, that I would introduce towards the end of this presentation something on our understanding of the wider seabed carbon storage potential. And this is work that we've driven from St Andrews. Very proud of this work. It's been delivered through projects funded both by UK and particularly Scottish government. And what I'm showing you in this image is a map on the left-hand side of the carbon that's stored in marine sediments. And on the right-hand side, a map of what's called the swept area ratio. So this is essentially mapping the pressure from bottom fishing, trawling on the seabed. And if we begin to think about our shelf seas with these vast amounts, I mean, we are talking very large quantities of carbon now being disturbed and potentially releasing that carbon ultimately back to the atmosphere, it may be that these pressures increasingly need to be managed to help reduce the impact, not only on benthic ecosystems, which are well understood, but also on our carbon cycle. And so this is an exciting area of travel, and it's one in which I think Scotland is making some progress. We've been publishing, so in the last 2 years, we've actually published some papers in this area, which are really, I think, helping to shape the agenda. So I'm very proud to show you those. But more importantly, I'll come in a moment to how that's going to perhaps translate into policy. I guess the key point to make here is that, and I'll recap now on some key points, that our systems are fundamentally linked. There are a range of coastal and ocean ecosystems that take up and store globally significant amounts of carbon. And as I've just said in that last slide, that carbon can be released if these ecosystems are disturbed by human anthropogenic activities. Our ocean ecosystems can be integrated into current climate policy. So we do have the frameworks to help us drive these changes. Seagrasses and salt marshes meet the criteria for inclusion in climate mitigation policy, and they're already recognized for their climate mitigation value. So they're recognized as helping the fight against climate change, and they're recognized at the highest international level by the Intergovernmental Panel on Climate Change. Now, you might want to ask me about macroalgae. We're seeing an increased interest in the licensing of seaweed farms in Scotland, and that's very exciting. And of course, macroalgae, seaweeds, kelp, and so on, do transfer some of their carbon into ocean sediment ecosystems. They're highly productive, and they're therefore almost certainly sequestering and storing carbon. The difficulty at the moment is that the evidence for the scale of this climate potential isn't really known. So this is an area of work which I think is going to develop very rapidly in coming years. The current evidence is that calcifying organisms, and of course, you might know, I showed that slide at the beginning of the Dornoch Firth and the Glenmorangie distillery in the background. And Glenmorangie, in partnership with others, have been restoring native oyster reefs in the Dornoch Firth. Unfortunately, whilst these don't fit the frameworks for carbon removal, these schemes are incredibly important at the seascapes scale for marine restoration, and they may well offer some improvements through the trapping of sediments rich in carbon. So again, these are systems that we still want to research and understand. I would argue that scientific research and capacity building, and I think capacity building, particularly in some parts of the world where these ecosystems are threatened and the policy changes haven't taken place, are going to be really important. And it's good to see that messaging coming from COP27 in Egypt at the present time. But, you know, we can view these ecosystems in terms of their climate service, their adaptation to climate, and the resilience that they give us. And then blue carbon ecosystems can and should be included in climate policies and actions. And I would commend the Scottish Government on the recent commitment to 10% of our seas as highly protected marine areas, these HPMAs as they're known. And I think uniquely, the recognition that in that designation process, blue carbon will be a consideration in the choice of some of these sites. And that's very exciting because it means that not only can we protect the most vulnerable ecosystems, perhaps because of rare species or biodiversity value, but we can also protect them because of what they offer in terms of their climate service. And then eventually, whilst I'm focused perhaps on the good news and good work of government, we ultimately need to recognize that governments alone aren't going to drive these changes. And this is, I think, where blue carbon can help us with innovative financing. And this will allow us to scale these actions across a number of blue carbon ecosystems. Many of these schemes are not going to be fully funded through carbon credits. And I think this is where putting climate and biodiversity together to understand the true value of nature, as Sapatha Dasgupta so elegantly showed last year when he published on the economics of biodiversity. our thinking has to change, and things are changing. And I must say that I remain hopeful despite some of the challenges which are being highlighted to us at the moment. So let me reflect on where we've been in Scotland. Colleagues at SNH, now Nature Scots, really drove this agenda early. There were assessments of these blue carbon resources. Really, this fits the framework of thinking about the marine environment as part of our wider natural capital. The wealth of our nation, if you like, is partly in our seas, in our natural environments. Scotland went early, and in 2018 included reference to blue carbon in the climate change plan, and we were very excited to see that happening. This was groundbreaking work globally. In 2021, ahead of COP26, the Scottish Government published an indicative NDC, that's the nationally determined contributions, and blue carbon were recognised as part of that commitment. Of course, UK as a whole reports through Westminster in terms of the national NDC, and blue carbon doesn't yet figure there. So again, I think I'd like to commend the Scottish Government for this innovation. And then ultimately, in the power sharing agreement between the SNP and the Green Party, we've seen a greater commitment. You know, whatever you think of this, we have seen these extraordinary commitments to our natural environment and to blue carbon in this process. And I think this is just fantastic. And I have to say, the world does look to Scotland for some of the innovative things that are happening here, despite some of the challenges we face, of course. So let me try and persuade you in a slightly different way. Last year, the World Economic Forum published McKinsey and Company, a very influential group, a consultation on nature and net zero. And this is a really interesting diagram, because what it shows us is the way in which we can think about natural systems providing a sink for carbon. And as we move towards 2050, on the right-hand side of the screen, we see that those emissions in blue are gradually reducing. So that's great news. That's what we want to do, but they don't bring us to zero. But in red, we see these negative emission technologies. And this is where nature essentially is a sink for carbon. So becomes, for example, reforestation, a negative emission technology. But what we see when we follow that thin wedge of the red is that the sooner we start this process, the greater the cumulative sink of carbon in these natural systems. And ultimately, they will help us balance out as we approach net zero. There's very difficult to remove emissions from our greenhouse gas inventories. Agriculture, for example, is going to continue to contribute some emissions. So we will need technologies, even if we reduce all other emissions. We will need help to achieve this. So in a slightly light-hearted manner, you know, we do need our trees, and I recognize that. But I hope I've persuaded you this evening that we also need our blue carbon habitats. And of course, for our seabirds, these are important habitats. And I was at a conference today. I gave a presentation this afternoon. I missed the opening speaker, who was the cabinet secretary, as she is now, Marie Goujon. And in 2019, when COP25 launched in Chile, Ms. Goujon joined me with school children at Montrose Basin. You may know the visitor centre there. And these children were collecting soil samples, and those samples are now part of a dot on the map for that citizen science publication that I showed you earlier. So that was a wonderful thing. And I have to say, you know, we appreciate the opportunity to engage with our policymakers in this area. So ultimately, where are we going? And I'm delighted to be able to tell you this evening that this year, here in Scotland, we've been chosen to lead a United Nations Decade of Ocean Science for Sustainable Development program for blue carbon across the global oceans. This is a global partnership, but the Scottish Blue Carbon Forum will lead this. And I'm very grateful to everyone who supported this. And we do, of course, want to build this interest and capacity in blue carbon right across the world. So I'll end there and thank you for your attention.
Bill, thank you so much for that talk. That's absolutely fantastic. Yeah, I was going to ask that on the screen. That's great. Thank you. Yeah, wonderful to hear all about your experiences, your research, and your expertise in the subject area. I think it was lovely to see your family has been getting involved as well. That's great for you to be able to use them. It's hit 8 o'clock, everybody. So if you need to go, then that's absolutely fine. But if you want to stay around and ask Bill some questions, if that's all right with you, just to answer some questions for a bit, is that okay?
Yeah, I'm very happy to take questions. And if there are some in the chat, if you would read them out, I'll try and answer them as best I can.
Lovely, yeah, not a problem at all. So I'll just go through the chat now. We've already had some coming through as you've been speaking, Bill, which is fantastic. But if anyone else has any others they'd like to add, pop them in the chat. We'll pick them up as we go through. So I'll start off at the beginning. And the first question came from Pete. And Pete says, I appreciate how important seagrass meadows are in Scotland, but are they protected? If in marine protected areas, are they free from dredging and other damages?
Yeah, that's a good question. I think, first of all, I would say that the extent of seagrass habitats in Scottish waters is not yet fully understood, but that we do understand at the UK scale that we've lost about 90% of those habitats. And I think many of you will know that they're very important nursery grounds for commercially important fisheries and all the other services they provide. No, they're not fully protected, as far as I understand. And one of the challenges that we have with our current MPA networks is that these do not fully protect the marine environment. And this is the distinction that I think we need to recognize, and the commitment to the highly protected marine areas is that they will essentially provide that complete protection. So I think, for example, you know, you might have a mooring that could disturb a seagrass meadow, and you know, that would probably you know, still be happening today.
Great, thank you. So more to be done going forward. Lovely. The next question was from Kerry. This was just to clarify on some of the terminology that was used whilst talking about the salt marsh research that you've been doing and the core sampling. She was just asking to define what realignment was meaning, and also additivity, if I'm saying that right. So just to help just explain that a little bit more would be great.
Yeah, thank you. I'm very happy to clarify. And I realized I was rushing and perhaps using, you know, the language that I use day to day. Managed realignment is a strategy that recognizes the potential for a coastline to be redrawn. And you know, a great example not too far away from the Scottish Seabird Centre is, in fact, the RSPB site at Skinflats in the inner Forth, if you know that site. You can go there and you can almost see as the tide comes in that realignment process. And what's happening there is that we're essentially typically breaking a coastal barrier and letting the sea in. So these are typically very low-lying areas, and the sea will come back in. Sometimes we do some groundworks, or the developers do some groundworks to channel the tidal flow back into that land. So that's managed realignment. Additionality is the term that's used. And the best example probably to give you is if I plant a tree that wasn't in my garden previously, that tree will start to, through photosynthesis, draw down CO2 from the atmosphere and build a store of carbon as it grows. And that would be defined as additionality. So the rule books are really not about using nature to do what nature's already doing. And, there are all sorts of moral dilemmas there, but it is about a management activity that provides an additional sink or store or protected store of carbon.
Great, thank you, Bill. Thank you for clarifying that. So just going through the rest of the questions, Maddie was wondering, please could you explain voluntary carbon markets further and how they aid in financing restoration projects?
Yeah, thanks, Maddie. I mean, that's a really exciting question. It's quite a dynamic area. It's fraught with difficulty. I do sometimes think we're in a little bit of a Wild West situation with some of the carbon trading. But the voluntary market essentially provides a way of selling the additional carbon. So you could sell to an investor, let's say 10,000 tons of additional carbon that your scheme will deliver within a given time frame. And the investor might be interested in that for a whole host of reasons. Perhaps, they just want to do good, or, and this is where it becomes challenging, they have some emissions that they're trying to offset. And so what they would recognize is that they can't get rid of all the emissions, but they would buy on a voluntary market an offset against the additional sequestration in that restored habitat. And that process, of course, allows a mechanism to fund restoration. So you can now, instead of perhaps just creating a habitat for wading birds, you can create a habitat for wading birds and sell some of the carbon to help pay for that scheme. So, that's where I think the financing becomes quite interesting. And there's a very high level of demand for these carbon credits and insufficient supply of good quality projects. So at the moment, this means that the voluntary carbon trading price is going to go up and up. So potentially of interest to investors in the real world as well.
Thank you, Bill. So that's basically giving almost an incentive for businesses and investors to invest in the green kind of economy. Yeah.
Yeah, I think it does incentivize. The danger, as I said at the very start, is that we can't do this without reducing emissions. It doesn't make sense. So, that is challenging because, you don't necessarily want somebody to keep polluting the atmosphere and just offset by buying, credits somewhere. That doesn't make a great deal of help to the planet.
Yeah, absolutely. Lovely. Thank you. Other questions coming in through here. So I've just scrolling through. Those are the ones I wrote down from the start. Just scrolling there with. Here we go. Tara's wanting to know if there'll be any more projects for the public to get involved in the area. And I think that's a wonderful thing to involve projects in citizen science, such a fantastic way to get more data and to involve the public. So have you got any plans yourself or know of any other projects that people can get involved in?
Yes, this is actually, quite a rapidly developing area for restoration projects. There is a team called Project Seagrass, and you may know them, and they do some wonderful work with community groups, essentially collecting seed and then trying to replant our seagrass meadows. The challenge there, of course, is to find the right sites where those projects will be successful. But I would definitely recommend your audience to look at Project Seagrass. In terms of the work at St Andrews and the work of the Blue Carbon Forum, we're very keen to, through some funding that we have, to do school visits and to share some of this knowledge. The pandemic has really upset some of those plans over the last few years. And we would love, and I have a group who would just love to come and, so if there's anyone on the call, perhaps with school kids and you'd like a visit, please do reach out. We'd be very happy to come and support something. And children love that muddy stuff. So it's great fun. And, this is, I think, the way to drive change is through the next generation.
Great, thank you, Bill. Yes, children love getting wellies on and going into mud. And also, just to flag, our team has put in the chat a link to a local restoration project happening in the Firth of Forth. The Seabed Centre is actually part of it. It's called Restoration Forth. And it's fantastic. It's a funding project we just got, and it started this year, and it's looking at restoring oyster beds and seagrass beds into the Firth of Forth. So fantastic work there. There's a link that's in the chat. If you click on that, it takes you to more information, and you can sign up to hear the newsletter and also get involved as well. So do check that out. Fantastic work going on our doorstep as well near the Seabed Centre. Lovely, thank you. Just scrolling back through again. James was wondering, how does the cost of managed realignment compare to other restoration projects, such as planting seagrass meadows, typically very expensive? And do you see much appetite for attracting private investment into managed realignment?
Well, I'll take my Scottish Blue Carbon Forum hat off for a moment. So, obviously I have a role in that area with government. But if I speak generally about the appetite from private investment, this is growing exponentially at the present time. The difficulty, James, is I think, where are those good projects that are really going to be successful? We have seen some seagrass restoration projects, which have been expensive. There's one in Plymouth which hasn't been particularly successful. And I think with some of those projects, we're still learning how to do those. The managed realignment, they tend to be successful. The additional carbon is relatively small, and the cost of the engineering works and buying the land, often it can be valuable agricultural land. So I think that's one of the challenges. Does make these projects difficult to get over the line. And this is where the stacked benefit approach, becomes really helpful, where the carbon is part of the financing for the project. I think we are going to see more of these. I would really like to think that we're going to see some here in Scotland. We've got a few of these, and I think there is, from that work that we've done, scope to have more of them. And there's certainly an interest. I'm involved in a UK project with colleagues at the UK Centre for Ecology and Hydrology. And we're doing a project at the moment with the Environment Agency. And in those examples, the Environment Agency primary interest is for flood protection. And so many of these engineering schemes can be designed to deliver improved flood protection. But in that process, you can create these blue carbon opportunities, and that creates a financing flow for these large engineering schemes. So I do think we are going to see more of these, but the costs are relatively high. And again, you know, the price of carbon probably isn't as high as it really ought to be in terms of, you know, the cost to us of all that carbon in our atmosphere.
Great, thank you. So we've just got a couple more, if that's all right. We had a question from Maddie. So Maddie is actually currently finishing a paper on how seaweed aquaculture can potentially contribute to carbon offsetting. Amazing work, Maddie. She's asking, what is your opinion on upscaling the restoration of kelp forests and macroalgal aquaculture around the UK in relation to climate mitigation?
Yeah, I mentioned in one of the bullet points about macroalgae, seaweed farming and kelp forests. And I am aware of, for example, the Norwegian Blue Forests project has been very influential in thinking about kelp forests on the Norwegian coast. And I do, Maddie, I do see growing interest in this. I think the challenge at the moment is to understand the carbon that flows from that kelp, where it goes to in the marine environment, and where it delivers the additionality. But clearly, if we could restore kelp forests, it's very likely that we're going to be building up these stores of carbon, and that can only be a good thing, both for climate and obviously for those restored ecosystems. So I'd love to read the paper, Maddie, when it's out. If you email me, I'd love to read that. Thank you.
Great. Yeah, maybe Bill, if it's all right, are you happy with us to provide your email address in a kind of follow-up email to everybody, if anyone does have any questions or papers to forward on to you?
Yes, I'm very happy to do that. And it was on the first slide as well, if you've recorded today. Great,
lovely. Thank you, Bill. And then we've got one more question that's come through into the chat from Joseph. I hope I'm saying that right. Joseph is involved with tree planting, meadow creation, amongst other restorative and habitat conservation work as part of my job role. Fantastic. What would be a similar set of activities that could be conducted with the voluntary third sector to deliver positive results to blue carbon habitat?
Yeah, I mean, that's quite a tricky question, Joseph, in terms of what could be done, you know, that isn't about managed realignment. I think some of these seagrass restoration projects work well. And I think where there are currently opportunities, if we go back to the Pollination Foundation work that I did with Hillary Kennedy, and thinking about the agricultural payments that we currently have, I think there's a huge potential, and this may intersect with your terrestrial land-based interest, in the way that we're managing, for example, grazing pressure or some of the practices on that land. And, you know, that could deliver at scale some really interesting benefits. And we've got some students at St Andrews who are sort of interested in those questions. And I think that would be the area that I would focus on. But I'm kind of looking at you there, Joseph. I'd be happy to have a chat with you offline, you know, later on about that. And I do think that's probably the way forward in terms of the blue carbon opportunities.
Great, thank you. There you go, networking happening at event, love it. Wonderful. Well, yeah, thank you everybody for those questions. I'm just scrolling through. I hope I haven't missed anyone. I think I've got everybody. So I think all that's left to say is a massive thank you to Bill. I know you're zooming in from a conference, from a hotel room, so thank you for giving up your evening to be with us tonight. Yeah, we'll make sure everybody that you get Bill's email address and a follow-up email that we'll send to everybody. We'll also provide everybody with the link to the YouTube recording as well, so you can watch bits back or share it with anyone that you like to as well. So just a heads up, so there won't be any more other online Meet the Scientist events this year, but we will be coming back next year with some new topics. So keep your eyes peeled on the Scottish Seabird Centre events page, or also sign up to our newsletter. That's a good way to keep informed of all our upcoming events. We do have some events happening at the Seabird Centre over the winter months, some nice Christmas craft activities and shopping events. So do look on our website to find out about those. But other than that, it would be great to get any feedback that you have about tonight. If this is your first time tuning in, we'd love to hear what you thought. Fantastic thing about these events is that we keep them free and accessible to everybody. So if you have any thoughts about future topics you'd like to hear on Meet the Scientist events, let us know. There'll be a link in the chat to a online SurveyMonkey form, which will just take a couple of moments. Complete that for us, and that'll be great for us to hear what you thought. But I think that's it, everybody, from us. So thank you so much for tuning in, and hopefully we'll see you again soon. Thanks, everybody.